Welcome back to chapter 13. This is video 4 of the chapter. So let's start by talking about the pathway for high thyroid hormone secretion. In order to get thyroid hormone, the thyroid to actually secrete its products, um, T3, T4, etc. It takes several different steps. So let's get through it. All right. So the very first thing that happened is TRH is secreted by the hypothalamus. Remember, TRH is thyroid releasing hormone. Remember that the hypothalamus is responsible for turning on or stimulating the pituitary gland. The pituitary gland is the master gland, it's called the master gland because it then controls several other endocrine glands. So you have thyroid hormone releasing hormone or thyroid releasing hormone coming from the hypothalamus. Remember, your releasing hormones and your release inhibiting hormones will typically come from the hypothalamus. That works on the anterior pituitary. So as the TRH is being released, and it goes through that portal vein that connects the hypothalamus to the anterior pituitary. Because remember, a hormone is defined as a substance that is released into the bloodstream. So that portal vein between the two, even though it's going to be very short, is very important to the overall functioning of this particular endocrine gland. So TRH is released from the hypothalamus, and then it affects the anterior pituitary. The anterior pituitary is then going to secrete TSH, thyroid stimulating hormone. So basically, now this is the hormone that is going to actually stimulate the thyroid to produce its own products. TSH will then go into the bloodstream and travel to the thyroid gland, and that is going to stimulate the thyroid to secrete its hormones. All right. Thyroid hormone can then go into the bloodstream and affect the target cells. Remember that target cells are those cells that have receptors on its surface for that particular substance. All right. So only a target cell will be affected by the increased amount of the hormones that the thyroid are secreting, because those will be the ones with the receptors. Thyroid hormones can also have a negative feedback on TRH and TSH. So think about it this way. You need your thyroid to secrete its hormones. That means that there is a relatively low amount of thyroid hormones. So your T3 and your T4, they're lower amounts. That low amount is going to be the signal that tells the hypothalamus, I need you to go ahead and click on and get this thing started because we need more thyroid hormone. So the low levels of thyroid hormone will be an indicator for the hypothalamus to secrete TRH. Then that is going to, stimulate the anterior pituitary to secrete TSH. And then that is going to then push the thyroid to secrete more T3 and T4. As those T3 and T4 levels increase and they get to levels that the body wants, those higher levels will then signal the hypothalamus and the anterior pituitary to stop making its products, which will have a downstream effect of decreasing the amount of thyroid hormones that are going to be secreted. So that is how that negative feedback works, in order to get the adequate amount of thyroid hormones produced by the thyroid. TSH secretion is controlled by two methods in this pathway. You have some control of TRH. So again, thyroid releasing hormone will control how much TSH, thyroid stimulating hormone, is produced by the anterior pituitary. Then you also have that negative feedback by the thyroid hormones. So give me 1 second. So let's go back to a previous slide so that you can see this visually. But right now, I want to look at the fact that TSH, thyroid stimulating hormone, that is secreted by the anterior pituitary, is controlled two different ways. Not only by the production of TRH, but also by the negative feedback of the thyroid hormone itself. So going back a couple slides here. So we have, this is the peripheral endocrine organ. In this particular case, we're talking about the thyroid. So as you can see, this is going to be how it works for basically all of the hormones. All right, basically. So peripheral endocrine gland. In this case, we're talking about the thyroid. So the thyroid is going to produce, remember this green, and the plus means go. That means everything is being produced. Red means inhibition. Negative means inhibition, means we're going to stop the process. So in order for this to produce, the hypothalamus sends its releasing hormone through the portal vein that goes to the anterior pituitary. That releasing hormone will then stimulate the anterior pituitary to produce its hormones, in this case, TSH, thyroid stimulating hormone. TSH will then stimulate the thyroid to produce T3, T4. As T3 or triiodothyronine and T4 thyroxine are produced, their amounts are increased. There's enough of it to get in the bloodstream and help the target cells. But as those amounts increase, you'll have a feedback loop that tells the anterior pituitary to decrease its production of TSH, and there is a also an effect on the hypothalamus to decrease its production of TRH. So so that's how you get basically that double control of the anterior pituitary. The feedback loop from the thyroid products stopping it, but then you also have the control of it from the releasing hormone. So let's go back. All right. So TSH secretion controlled by two methods. Remember, TSH comes from the anterior pituitary. It is controlled by TRH and the negative feedback of the final hormones in the pathway, those hormones produced by the thyroid. So again, same idea. You can check it out. So let's talk about this clinical application. This is what happens when you have too much or too little growth hormone. So this is going to be an example of what can happen if you don't have that tight regulation of these hormones in the body. Remember earlier in the chapter, we talked about how closely regulated each of these hormones are, and how you have all of these feedback loops to have these checks and balances that will control and monitor how much how much a particular hormone you have in the body, and the body tries to keep this in the bloodstream at a narrow range. So, growth hormones, hypopituitary. So, growth hormone, remember, is produced by the pituitary. Hypopituitary dwarfism. Remember that a dwarf is a little person, right? A dwarf is a small person. So think about small person, small amounts of growth hormone. Growth hormones help you grow. Since they are dwarfs, they didn't grow very well. They probably didn't have much growth hormone, which they did. So, hypopituitary dwarfism is caused by a deficiency of human growth hormone during childhood. And it's important to understand that it's during childhood because remember, childhood is when your growth plates are open. While your growth plates are open, that means your bones are ready, willing, and waiting for the signal to say, I need you to build and grow, become longer. So there's a short stature in these dwarfs, but their body proportions and their mental development are normal. So these would be the people that are just extremely short, but they have what we consider um, normal body proportions. If you think about other people who are short, little people, some of them have body proportions that are different from those who are average size. But for hypopituitary dwarfism, their body proportions will be normal, and their mental development will be normal. HGH, or human growth hormone treatment, must start before the bones completely ossify. Um, if the practitioner, the parents and the practitioner notice that baby is not growing taller, they're not reaching certain milestones, then they can um, take the next steps to do some testing to see how much human growth hormone that person, that baby is producing. And when they find out that they are producing too little human growth hormone, then they can inject or give them exogenous human growth hormone. All right, so they want to do that before the bones start to ossify so that they can get some height before their growth plates close. So that is hypopituitary dwarfism. Gigantism. Gigantism is caused by oversecretion of growth hormone during childhood. So again, growth plates are open, which means that if human growth hormone is being oversecreted by that person, then because their growth plates are still open, their bones are going to grow longer than the average person. So this person's height might exceed 8 feet in some cases, and they might have other metabolic problems because their body is basically in hyperdrive because you have this excess of growth hormone. It can be caused by a pituitary tumor. So, why would a particular hormone be overproduced in the body? The reason why it would be overproduced is that you have the cell that is producing that hormone has then has gone rogue and started to reproduce itself at high rates so that now all of the cells that are made from that damaged cell are also producing excess amount of that particular hormone. Each cell will produce one product. So even though the pituitary gland is very small, remember that it does not take a whole lot of hormone to get an effect. So if you have extra cells that are producing growth hormone before the growth plates are closed, then that person will be exceedingly tall. Acromegaly is caused by the oversecretion of growth hormone, but the difference is that it occurs during adulthood. So you know that adulthood is defined by at least one part of it is there's no more growth in height. So if this person has an increase in secretion of growth hormone, after their growth plates have closed, then those bones will be affected in different ways. Their body will be affected in different ways. Their bones can no longer grow longer. So, whatever height they were at puberty or once they stopped growing, that's the height they're going to remain. They're not going to get any taller. But as you can see from the second line, their bones do get thicker. So the bones are still being affected, Their bones are still being affected. Their bones are still growing in some way. They're just not growing longer. What happens is the bones will start growing thicker. My assumption, I don't know this for sure. You all can look it up, but it is probably going to be an increase in the the compact bone, but possibly also spongy bone. So, um, bone thickness will increase. They'll also have an increase in other parts of their body. So, an enlargement of the nose, the tongue, the hands, the feet, the jaw, the heart, and the thyroid gland. So, people who have acromegaly, their physical appearance starts to shift from what they are accustomed to seeing, their adult look to a sort of typical look of those people that have acromegaly. If you know who Andre the Giant is, Andre the Giant, um, had acromegaly. He may have actually had an increase in growth hormone production before his uh before his growth plates closed. And I only say that because he is an extremely tall man, or he was a tall man, as well as having those distinct features. But if you look at Andre the Giant, you'll notice that his face has this squaredness, this thickness to it. His tongue, when he speaks, or when he spoke, his tongue was kind of thick. That is sort of the typical look of someone with acromegaly. All right, that was all anterior pituitary. Let's start talking about the posterior pituitary and the hormones that it produces. The posterior lobe of the pituitary gland consists of nerve fibers from the hypothalamus and neuroglia, unlike the glandular epithelium of the anterior pituitary. So when you look at the pituitary, you notice that it has two parts. It sort of looks like testes, of course, when you look at it, but let's think about that as being two halves of the same organ. The anterior pituitary is glandular. That is why it's going to produce these hormones, and those hormones will be secreted into that portal vein that connects the hypothalamus to the pituitary. Well, the posterior pituitary is less hormonal or less glandular, and it's more nervous tissue. All right. So earlier when we talked about the neural hypothesis versus adeno hypothesis, I hope you looked up the difference between neuro, or the definitions of neuro and adeno, so that you can identify those two. Um, but that is the difference. All right. So the posterior pituitary produces two hormones. I'm sorry. Um, Two hormones produced in the hypothalamus are then stored and released by the posterior pituitary. So, posterior pituitary is not going to produce its own hormones. It is going to store and release the two hormones that are produced in the hypothalamus, and then basically deposit it into the posterior pituitary, so that it's released when it's needed. These hormones are transported to the posterior pituitary via the pituitary stalk, or the infundibulum. All right. Those two hormones are ADH, also called vasopressin. ADH stands for anti-diuretic hormone. The other hormone is oxytocin. So let's talk about ADH, or anti-diuretic hormone. You may recognize the term diuretic. Many people with hypertension or some other type of water conserving condition will take diuretics. Diuretics are substances that increase urination. So it starts to pull water out of tissues, it pulls water out of the bloodstream, it deposits it into the kidneys filter it out so that then it goes into the bladder, so that you urine urinate though that excess fluid out of the body. That is what a diuretic is. Antidiuretic hormone then has the opposite effect. So this hormone is produced when your body wants you to release less water, when you want to retain some water, right? So antidiuretic hormone decreases urine production by reducing the volume of water that the kidneys excrete. Um, ADH, antidiuretic hormone, causes vasoconstriction. So part of the reason, I'm sorry, part of the one of the names of ADH is vasopressin. When you look at that, the vaso means blood vessels, vasopressin. The blood vessels are pressed in, right? When you pressed in, you constrict it. You cannot do as much because you all being pressed. Vasopressin. So antidiuretic hormone causes the vasoconstriction of the blood vessels in the kidneys so that you have less blood flowing through those blood vessels through the kidneys, meaning you are going to have less water or fluid being excreted from the body through the kidneys. Now, as your body retains more of that water, more of that fluid, that is going to lead to an increase of blood pressure. So if your blood pressure starts to decrease, then your body will produce more ADH so that you can retain more water, you can urinate less, and now that means you're going to have more of that fluid in your bloodstream, increasing your blood pressure. Another time that this may be produced, or the increased production of this, is if you are outside on a hot day for any length of time. If you've ever paid attention, when you say, let's say you have a family picnic and everybody's outside, and of course it's late spring or it's summertime and it's hot outside. But you're still outside having a good time. Sun is on you and it's beating down and you're sweating. Your body does not want you to urinate out very much because now you need to conserve that water, especially if you're not drinking adequate water to replace what you're sweating out. So there are several instances where you will produce ADH. Um, in my experiences, once say I've gone all day, if I'm outside or that entire time without having urinated, once I get inside and the body starts to cool off, then your body is okay with decreasing ADH um, production so that then you can start to urinate because no, you no longer need that excess water in your body. Oxytocin is a hormone that causes muscle contraction in the uterine wall during childbirth. So as mom gets closer to her delivery date, her body will start to increase production of oxytocin so that the muscles of the uterus, because the uterus is basically a big ass muscle, the muscles of the uterus will start to contract and in preparation of kicking the baby out of the uterus so the baby can be on her own and mom can get her body back. Oxytocin will also cause milk ejection during lactation. It's not going to cause the production of milk, that's prolactin. But once the milk is produced and it's in the mammary tissue, it's in the breast tissue, oxytocin will help that milk come out of the breast in order to feed baby. Oxytocin hasn't had, or they haven't found a function of oxytocin in men, but oxytocin is produced by people born male. And it may be that oxytocin helps with sperm movement or maybe even sexual response. They're still doing research to see how oxytocin affects people born male. So This is a snapshot of all of the hormones produced by the pituitary. You have those produced by the anterior pituitary, those produced by the posterior pituitary. So if you are a visual learner, here you go. So now let's talk more about the thyroid. The thyroid gland has two lobes. These lobes are lateral, right? So when you look at the thyroid, it sort of looks like a butterfly. So the major parts of it are going to be on the lateral aspects of that organ. What connects those two halves is this little piece of thyroid tissue called the isthmus. Isthmus. All right. So two lateral lobes connected by an isthmus. It lies just below the larynx, so the throat, the voice box, and anterior and lateral to the trachea. So when you put your hand on your throat and you rub your hand up and down, you feel the bump, bump, bump of the trachea or the windpipe. The thyroid then is going to be in the lower or distal aspect of, or the inferior aspect of that trachea, um, but anterior to the trachea, so in the front of the throat. And then those lobes are going to sit lateral to the trachea. The isthmus is going to sit on the anterior aspect because that's what's connecting those two halves. The thyroid has a special ability to remove iodine from the blood. That's important because that iodine is then going to be used to make some of the thyroid hormone. So let's look at the thyroid hormones. You have three different hormones. You have three different hormones produced by the thyroid. Let's look at T3. Let me say it first. We have T4, T3. Those are, the short names, and calcitonin. Let's look at T3 first. So T3's name is triiodothyronine. Triiodothyronine. It probably will help you understand why it's important for the thyroid to have this special ability to remove iodine from the bloodstream by looking at these hormones. So T3, triiodo. Iodo is the medical, basically the shortened medical term for iodine. Tri, of course, we know that means three. So this molecule has three iodines attached. So in order to make these two thyroid hormones, the thyroid needs to be able to remove some of that iodine from the blood to produce this product. T3, three iodines. So hopefully you guessed T4 has four iodines. Now, it doesn't say it on here, but T4 is the less active form of T3. T3 is the more active form. So maybe you've guessed that in order to make this active, you popped one of the iodines off, right? So the big bulky T4 has all four iodines. That's why it's less active. It's inactive because it's big, it's bulky, it has too many iodines. Pop one of those off. Now you have T3. It's the active form. Follicular cells are the cells that are producing T3 and T4. Follicular cells. Extrafollicular cells. So those cells just outside of the follicles are those that will produce calcitonin. And we already know that calcitonin has a function of monitoring and maintaining calcium levels. The thyroid is composed of round secretory units called follicles. Each follicle is surrounded by a single layer of follicular cells. A single layer of follicular cells. So think about last semester when you studied cells, it was chapter 5, the tissues chapter, when we talked about glands and we talked about those, say, simple cuboidal epithelium. You know that, or Yes, I'm going to assume that you do know this. You know that it was a single layer of those cells surrounded by that surround a lumen, an open space. That's basically what a follicle is here. So a follicle is a space that is surrounded by a single layer of follicular cells. And in that space, inside that follicle, we have this viscous colloid. All right. So viscous basically means a thick substance, right? Like a gel kind of substance. Colloid is also another word that refers to the consistency of a substance. So make sure you go to the dictionary and look up viscous and look up colloid to have a better understanding of the substance that is filling the cavity of these follicles. So these follicles, again, are surrounded by a single layer of follicular cells, and then anything outside of that is extrafollicular. It sits outside of those follicles, and it's those extrafollicular cells that is producing the calcitonin. So this is the larynx or the voice box. This is the trachea. So again, when you palpate or when you touch the anterior aspect of your throat, you feel bump, bump, bump. That's the rings of the trachea. The thyroid is a bilobed or two-lobed organ that where the lobes are lateral and each lobe is connected by a piece of tissue called the isthmus. All right. So when you take a piece of the thyroid and you look at it, you see that you have these follicles. So this empty space surrounded by a single layer of follicular cells, and then everything else are the extra follicular cells. And it's the extrafollicular cells producing the calcitonin. It's these follicular cells that's producing T3 and T4. And it's that colloid that is in the middle that basically is receiving that T3, T4. This is what it actually looks like. So the first one was a drawing, and this is what it actually looks like. So colloid, follicular cells. Colloid, follicular cells, extrafollicular cells. All right, all of this is colloid, several different ones. So you can see that in the thyroid, you have so many of these that are able to produce that T3 and T4. All right, so T4. T4's job is to increase the rate of energy release from carbohydrates. It increases the rate of protein synthesis. It accelerates growth. So basically, T4 increases metabolism, increases those metabolic processes. And that's how you get the increased release of energy from carbohydrates. You make more proteins, you grow faster, etc. In order for your nervous system to mature properly, you must have T4. So let's think about that. If a baby is born and their thyroid is not functioning properly, and the doctors don't catch it early enough, their nervous system will not mature properly. So, what does that mean? Remember, the brain is part of the nervous system. So, that might mean that they have sensory deficits, that might mean that they have motor deficits, but that will also probably mean that they will have mental delay because their nervous system is not able to mature properly. T3, same as above, but it's much more potent than T4. Triiodothyronine is much more potent than T4, but it pretty much does the same thing. So remember I said that T3 is the active form or the more active form. T4 is the less active form. So you have less T3 being produced by the body because once T3 is released, lots and lots of activity is going to happen. We produce T4 then so that you have less activity, but then T4 can go around to the body and it can become T3 to become the more active, more potent form. Calcitonin lowers blood calcium and phosphate ion concentrations. So, if you have increased amounts of calcium in the blood, if you take lots of calcium supplements, or you start eating a lot of calcium-rich foods, then your blood calcium levels are going to increase. And that's when the levels of calcitonin will start to increase so that it can then lower the amount of calcium and phosphate in the blood. So let's talk some disorders of the thyroid. So there's a lot of different ways that your thyroid can be negatively impacted and cause um, problems in the body. Basically, there are two there are two basic categories of it. You have hyperthyroid and you have hypothyroid. So, hyper means increase, excess, up, above. So, hyperthyroid conditions are those conditions in which the thyroid is producing too much thyroid hormone, too much T3, too much T4. Hypothyroid is the opposite. Your thyroid is producing too little thyroid hormone, too little T3, too little T4. So, by as you can see, there are two different ways that hyperthyroid can occur, four different ways that hypothyroid can occur. So it's really important to understand the differences between them as healthcare practitioners so that when you, your family, your patients seem to have increased or decreased metabolism, you can treat it adequately. So, hyperthyroidism, just in general, the term hyperthyroidism is a high metabolic rate, which means that everything is moving really, really fast, right? Because the thyroid hormones affect metabolism. So if you have increase in thyroid hormone, you'll have an increase in metabolism. So everything is moving faster. When things move faster, they heat up, right? So this person will have a high metabolic rate. Think about people who have high metabolisms. They're typically thin people because their body is burning through energy, burning through resources. They're also heating up. So this person is sensitive to heat because everything in their body is heating up because they're moving faster. They're restless because everything is moving faster, right? They're hyperactive, obviously, because everything is moving faster. Again, we already talked about the weight loss. Something that's interesting that happened is they have protruding eyes. I'm not exactly sure why that is, but that is a typical look of a person that has hyperthyroidism. And then they'll end up developing a goiter. Goiter is that basically that big puffy neck. The anterior aspect of the neck is big and puffy, and that's because the thyroid itself becomes hypertrophic. The thyroid gets bigger. Then you have Graves' disease, which is also um, a hyperthyroid condition, but what causes that is autoantibodies. So the body starts to produce antibodies against the TSH receptors on the thyroid cells. So this too will cause a protrusion of the eyes. That's called exophthalmia. exophthalmia, and it'll also produce a goiter. So hyperthyroid conditions will typically have a goiter and protruding eyes, but they can be caused by um, two different things. One is just the increased production of the thyroid hormone, and the other is an autoimmune disease. Hypothyroid. Hypothyroid conditions, you have again four. You have Hashimoto's disease, which is also an autoimmune disease where you have antibodies. So autoantibodies, antibodies against self. Remember, think when you hear auto, think self. So autoantibodies that start to destroy those follicular cells, those thyroid cells, and as those cells become they get destroyed, that means you have less and less cells producing thyroid hormone. So that is going to contribute to the hypothyroidism. Infantile hypothyroidism, basically hypothyroidism in an infant that is going to cause stunted growth. Remember, thyroid produces hormones that affect metabolism. And if you don't have adequate thyroid disease, I'm sorry, adequate thyroid hormone, then you won't be able to grow as well. So that person will have stunted growth. They'll have abnormal bone formation. They'll have intellectual disabilities, and they'll be sluggish. Remember, sluggish, everything is slowed down because there's less thyroid hormone, which means there's decreased metabolism, decreased growth. If a person has hypothyroidism as an adult, their growth won't be stunted because they've already grown. Their growth plates have their bones have already grown, growth plates have already closed, so they don't have stunted growth, but they will have a low metabolism. When everything slows down, your body is not as warm because you don't have as much metabolism. So these people are more sensitive to cold because of the slower metabolism. They're sluggish. Remember, decreased metabolism, decreased energy production. That means everything is slower. The appetite is poor. You don't want to eat. It takes a lot of energy to digest food. And if you don't have energy, you don't want to digest food, so you have less of an appetite. And then you have mental dullness. As everything slows down, it's really hard to think when everything is slowed down. Simple goiter. So, a simple goiter is a deficiency of high thyroid hormone due to a deficiency of iodine. So, if you ever noticed the salt that is in your kitchen, especially if you just get standard salt, then when you look at the package, it'll say that iodine has been added, or this is iodized salt. The reason they do that, especially in developed countries, is to make sure that the population as a whole gets adequate amounts of iodine introduced into their bodies so that we're less likely to have a population of people with simple goiters caused by iodine deficiency. People who eat lots of sea vegetables and sea animals, especially sea vegetables, though. Sea vegetables are where you get a good amount of iodine. So people who are coastal, they will get that naturally. But in this country, we put iodine in the salt so that we can avoid iodine deficiency. We can avoid simple goiter. So when you look at it, this is infantile hypothyroidism. So remember, you have the enlarged tongue. This baby has mental delay, mental disabilities because of the hypothyroidism that occurred in infancy. And all of these infants will have a very similar look. This person has hyperthyroidism. You see the bulging, protruding eyes or the exophthalmos. You can also see the increased puffiness of the neck. That is that thyroid that has enlarged. You can even kind of see the outline of the two lobes of the thyroid and the thickened isthmus in the middle. All right, so big goiter and exophthalmos. Now, this person has a goiter, huge goiter. This is a simple goiter, but they have no exophthalmos, right? So this is typical of the hyperthyroid, and this is typical of hypothyroid, simple goiter. So this person lives in a community that has not iodized the salt, which means she has an iodine deficiency, so her body's producing less thyroid hormone. So infantile hypothyroidism, Graves' disease, so this would be the autoimmune hypothyroidism. I'm sorry, hyperthyroidism, and this is simple goiter. Let's stop there and we'll continue in the next video.